And the only thing I really want to say from my side is to reconcile the equation that I give in the slides with the one that you can find in fogler. So the difference here, and I apologize for that because I started off with saying I have I as the index number to indicate my components in my slides, with J the reactions, and fogler has got it the opposite way around. So he uses J, so you will have J's over there, and he will have I's over there. Okay. Pain to code correctly. Yes, I agree with that. It's definitely a pain to code correctly, and it becomes here. You've got a memo in this TAT. So let me just go on a sidetrack here. In TAT 5, you've got a memo, so you know that you are wrong when you are wrong. But when you are really designing something, like in your CPJ design, you've got no way of knowing that you are wrong, except if you've got really unrealistic values, like finding a catalyst mass of 7 grams to process something, a flow rate of 10 tons per hour. But it is a pain. Units is often a big culprit. Units or a big culprit. So pay attention to the units and you must be like an accountant. And that's the reason why I give this online test, is to give you a suggestion of in future work when you start to code for systems that you don't have a memo for, that you can at least check the size, the relative sizes of your differential equations. Does it make sense? If you get, for instance, a dT/dV, if you get a dT/dV, and in your first when volume is equal to 0, so that first slope, how the temperature is going to change with volume, if you get an answer for that like 1,000 Kelvin per cubic meter, then you know something is wrong in my units, in my energy balance. Or if you get for your dP/dV equation, if you get something like, let's say, plus 5 bar, then you know it can't be a plus, the pressure must go down. So there's a sign error there, and 5 bar per cubic meter is also not that realistic. So it gives even if you got the TAT 5 correct before you could do the online test, which helps you to debug your code. Use it as an example for future work on how to potentially find errors and mistakes, especially in stuff where you can make a typing error in a rate equation or in a delta H equation or in a CP value. And now in this del H, you've got the extra fact that you want to say the del H at any temperature is equal to the del H of the reaction plus del CP reaction times temperature minus the reference temperature where this is available, as you must employ in TAT 5. Okay, so pick up mistake when you mark this section during CPJ. Yes, how do I pick up mistakes? I check, so what I do is I check the mole balances. So I check whether if you say, and so now it's not A, B's and C's. You will have carbons, you will have hydrogens, you will have oxygens. I check whether in your profiles, if you model different components, so let's say you've got a C4 and you've got a C5 and you've got a C6 that you model, and you start with a certain amount. It's often easy to check if I count C5s at a certain step, the carbons at a certain step, do the mole balances actually balance? That's a way of picking up a mistake. Also, so that you must definitely check. Does my stoichiometry make sense? My right, like the errors made in the semester test. That is what I see. If I see something unrealistic, like, and I ask for that weight hourly space velocity calculation in your assignment, so you will have to do some self-study on finding what does it mean, what's that value. If I see you've got totally unrealistic values for that, that's outside of an industry scope, I know that something must be wrong, and then I go and have a look. So when I mark, of course, I don't have enough time to find detailed mistakes, but I can see whether something is realistic or not based on how the reactor looks. So looks count a lot. because I can see when you give me the length of your reactor, the diameter of your reactor, the number of tubes, the diameter of the tubes. I look at that, and if I see you've designed a reactor that looks like a pancake, I know, something is wrong. If I see you've designed a reactor that looks like a lamppost, something is wrong. For me, looks count when it comes to reactors. Right, looks very important when it comes to reactors. Right, so let's stop blabbering about that. But that's for anyone as well. Is it? Am I scribbling off the page? Please just tell me, somebody. Perfect for you. Right, anybody else? So you can see it says Josh, I'm just going. Okay. Off the page. Okay, let me zoom out. Let's just see. I see everything fine. Okay, those who see it fine, have you zoomed in and zoomed out, or what's happening? Maybe you've zoomed in. Can you just say those who can see the scribblings? Can you see that I've now circled the right? So very concerning.
Yes.
Okay, all right. So maybe you should zoom in, people. I'm zoomed in. Thank you. All right, so make sure that your view is adjusted to my view. I apologize, I don't know how to fix this issue. Right, but what I want to do now, going slightly off track, is to reconcile, so except for the switch between I and J, right, I and J, the other other thing that looks different in Fogler is this term. Fogler writes this as a dog reader. Fogler uses this as sum over the reactions J. Okay, well, he's got I, but I now have reactions J. And then he says it is min R of J, min del H of reaction J. And let's just see, why does he do that? So let me just open a whiteboard. Then maybe everyone can see better. So Fogler says the term for the reactions is sum for each of the reactions J, min R of that J, I in J, right? And then also a min del H of that reaction J. In my equation, I have R I J, min R I J, divided by the stoichiometric number of I in J, just times del H R X reaction J. So he's got an extra negative sign there. And of course, what he does is when he writes his balances, so let's say I've got 2A that forms B. Right, 2A that forms B, so I form that isomer. He will do the following. He will say, I'm first going to divide my reaction by that stoichiometric number. So I'm going to write it in terms of A goes to a half B. If I calculate this delta H of the reaction based on this reaction stoichiometry, and I consider this one, delta H of this reaction, I will get this version 2, this is version 1. It's the same reaction, just version 2 and version 1. This one is going to end up being half of that one. I hope you agree with that. So that is still per mole reaction, but it will change depending on this stoichiometry. So for Fogler, he writes all his equations that coefficient there, the stoichiometric number of the reactant that he used to base his calculations on, is always -1. And therefore, so we have that as a variable. So if I substitute a -1, I've got that extra -1 there that is given in Fogler. So hopefully that makes sense to you. Why I choose to do it this way, it is just more, it's less breakable. Your code is less breakable, and the way you understand it is less breakable than building in stuff, and then suddenly you are confronted with a reaction where the stoichiometry is not 1, 1, 1, 1. also not for your limiting reactant on which you are going to base your reaction rate. Right. So for me, it's more robust. That is what I wanted to say. This is a more robust way, in my experience, and students don't struggle that much when they have to then expand if they use this nomenclature. So for fogler, this, to summarize, this is always equal to -1. This is always equal to -1, and that is why, let's just go back to the slides, share files, okay, share, this one, okay, right. So that is why Fogler in his equation there doesn't have that, but he's got min r I in j min del h r x j. This is always -1 in the way Fogler manipulates his equations. Any questions on that? Right? Going. So let's just go to the CSTR. Because we always has no. Okay, let's just go back. Okay, Anna says we always have it as +1. Remember, it can be +1 or -1. If it's a reactant, A that goes to B, this is a -1. For reactants, as it's written, this is going to be a -1. But we now have the flexibility of saying, I base my rate on the formation of B. This, and then that is going to be a +1. Okay, let's just check the question over here. Are you happy, Anna? Remember, this has got the sign associated with, for reactants, it's a negative number. For, okay, you see, thank you. Right, okay. So I just wanted to go to the slide that gives the CSTRs. CSTRs are crazy to solve. Crazy to solve for multiple reactions. And you will not see them popping up in a TUT and in a test. But just for your future use, if you save the slides and you end up in industry where you have to model a CSTR with a multiple reaction, it's going to take you a while to sort out all the multiplicities in terms of the analytical multiplicities, because you're going to end up with lots of nonlinear equations that you must solve simultaneously, and you can have multiple solutions. Some of them will actually be possible operating states, but others will just be artifacts of the math. So that's a very unfair question to ask if you don't have 3 weeks to solve. Okay, so I stopped. I once had TUTs on multiple reactions in CSTRs, and I had to give bounds of search in that bound for the temperature, search in that bound for the molar flow rates, which I am not going to expect of you in this course. But the same thing over here, there, Fogler, now, just his equation is just what is the rate of I in J and what is del H. So he's got a positive number there. And that's once again because his stoichiometric number Ij is always based on a reaction that looks like this. A goes to products. And therefore that stoichiometric number is always a -1. So it's a negative divided by a negative, and then it becomes that positive value that Fogler gives in his equation on page 548. Right, so that I had a question earlier before the semester test, Philip, it was you. I asked, can you please reconcile with Fogler? I hope you are happy. Philip?
Yes, thank you, ma'am. I am.
All right, cool. Okay, so if there are no other questions on multiple reactions, I want to discuss something about the assignment. So let's just give a moment for hands, please. No hands. Okay, right. So I'm going to stop the recording and start a new one.